There, hello, yes, let's go. Okay, stop the count. Chef is participating in election, going up against his enemy, anti-chef, and voters. Voters are rising. One means I voted for chef. Vote is equal to number. So at any point, chef can stop the count, and even if it is not counted, so that is not a win. Stop to the count after all inputs have been counted. Okay. So at any point, if chef is winning, he will stop the vote count, right? So 1, 2, 3, 1 and 2. 2. Okay. Let's take a string s cns for auto x s. If x is 1, cnt plus plus, else cnt minus minus. If cnt is greater than 0, res will be plus plus, and cout res and l. Now int cnt is 0 and res is 0. Deleting array, again you have an array of size n, cost array c. Exactly in operations, choose I such that and delete ai from the array. Associated cost is correct. Associated cost is this much, then delete ai from the array. Okay, the associated cost is ai into ci, ai into the cost index. Okay, the cost value. After each operation, the remaining parts of the array are concatenated and reindexed. Okay, note that array c is not modified. Array c is not modified, so the pairings will change, right? Minimum total cost needed to perform the n operations. So ai into ci, find the minimum. I think greedy approach. Find the minimum ai into ci. Then ci is the same. Find the minimum ci if I say. So at each point I need to find the minimum ai into ci. If I find the first minimum ai into ci, okay, n square will work, right? Mm, this is what the question means, right? So 4 and 2 and 1 and 2. 4 into 1 is 4, and 2 into 2 is also 4, but this got removed, right? So 4 will get removed and then 2 will get removed. The element with the bigger ai. If we have the same, then element with the bigger ai, right? And vector int c of n. Mm, so this operation will be performed n times. What is the operation? The final index is going to be less than I, right? So int j int l is equals to 0, comma r is 0. So vector int rem. Let's see which indexes have been removed. Okay. So while L is less than N, obviously, L is iterating on Vi. And if L is double equal L, if rem L, then L plus plus and continue. If L has been removed, then L plus plus continue. Else int res is equals to 118. What is the value here? It is A of L into C of R. Okay. I have to also find the index removed. Okay. If value is greater than is less than res, then value will be res and idx will be L. Else if value is equal to res, then so if value is equal to res and mm, A at idx is greater than okay is less than A at L. No, A at L, yes. Idx one is less than L, so this is becoming the current one. And after doing all of this thing, you can say that rem of idx is equals to 1, right? Rem is 1 and here I forgot R plus plus. Rem is 1 and answer will add res. Oh, what is happening here? What am I doing? Otherwise L will be plus plus here as well. I'm missing something really easy or what? Idx is 0. Idx is 0. Yes, Idx is 0. Is less than N, that's fine. Okay, let's try this. Mm, mm, mm. Okay, there's some ordering mistake. You have an array cost C, exactly an operations of function. So choose I, delete AI from the array. The associated cost is AI into CI. it, it should be copy. So in the n elements, I will choose the one with the minimum AI into CI, right? And among those, I will choose with the maximum AI. If value is equals to res, then in A at IDX is less than A at L. Only then I will say that I'll choose this now. Or I should say, so greedy strategy is going wrong, but what should I delete? I'll choose the minimum AI into CI, that's sure, but if multiple have the same value, then okay, let me see like this. Uh, this element can only be, the zeroth element can only be deleted with the first CI. Okay, the prefix min. The prefix min. This can be only deleted with this. Second element can only be deleted with this or this, right? So I have to find the prefix min, right? Vector int pref min and n ref min 0 equals to c of 0 for int I equals to 1 I plus n and I plus plus ref min I equals to ref min I minus 1 comma ci, right? Ci. Done this. Now the answer will be answer plus equal to ai into pref min of I. Mm, this should be it. Submit. That's why there are so many submissions on it. I overthought. Okay, how many on this? 83. Cool. Count array. Okay, counting optimal less for an array of size and define FAR summation of AI into AI XOR AI plus 1. Okay, so AI XOR, so AI A1 XOR A2 plus A2. Okay. XOR FA is defined as 0 when n is 1. Okay. Given it is an n and m, count consider the array as A satisfying a mod equals to n. Okay, size is n and elements up to n as known the maximum possible value of FA. Find the number of array satisfying the constraints so that FA is equals to S. So which values have FA as the maximum and all elements are up to m. Okay, for n equals to 1 there are 7 different types. For n equals to 2, 4 optimal arrays. What are the optimal arrays? They have a XOR of 3. Okay, and for XOR of, so it is equal to n. So I have to have 2 elements and any other constraints. 1e8. Okay. I can just do 0303 something like that. So it is 0 and 0 and 0 m. Is it fine? M0 will also work then. 30 will also work. So these combinations into 2. If I'm supposed to have 3 elements, then I can have a maximum of 2m. Can I have anything better than that? 2m or the log of I mean the I can have a maximum of like I'm choosing that, so so there are two numbers which will be alternating and we have to find the two numbers and those two numbers can be from if I have two, so I have if m is 3, then I have two bits. Both bits are set in this, one is set in this, at this and this. So I have four possibilities. For 420, mm, we have 100 elements. That does not matter. What matters is 420. So I can have uh, 1. Okay, from this I get the answer 330. There are 330 arrays. That means there are 330 numbers or 115 numbers. No, 330 means 185, 165. Mm, 330 numbers. How did you get that? The numbers can be alternating, will have to be alternating, such that the XOR is like 420 has this, so Uh, I'm getting something like mm, okay, close enough. Let's try edge casing this one. Array plus one. I have not yet proved the solution, but let's see. Cool. So basically, it was like taking only the first set bit from here, and I can like starting at 256, then 257, then 258 up till 420. I can make pairs of like 256 and its XOR with 420, and then 257 and XOR with 420. Those pairs I can make, and into two because there are two kinds of alternations. Hmm, cool. Blat's conjecture easy, right? Easy and hard is there. Cool. You are given an integer n, you can do following operations if n is even, choose to change n to either 3 XOR n plus 1 or okay. If n is odd, I have to forcefully change it to 3 XOR n plus 1. Okay, good question. And what is it? 115. What is hard then? Find the minimum operations, okay. Let's analyze. If n is even, 3 XOR n. So it is already n plus 1 because in 3 the last word is set and an even number is not set, so plus 1. And then XOR with this. If okay, 3 XOR n plus 1. This one also. So if it is already set there, then it will become unset and then again set and 0. If first bit, not 0th bit, if the first bit is set in n, it will become, finally what it will become, if the first bit is set, then like I mean like this, so what will happen is XOR 3, so 2 XOR 3 will become 1, and then plus 1, so it will again become 2. So XOR 3 plus 1 will not make difference, become n. If first bit is set, it will become n, so that should not be done, right? We will not converge to 1. Am I correct? If first bit is set, then XOR 3 will give 1, and then plus 1 gives again the same number. Yes, so it will not change. Else, what it will become? Like it will become set, so this is like 100. So this becomes set and then plus 1. So it becomes plus 3 and plus 1, so it's plus 4, n plus 4, n plus 4. Still remains even? Is it so? 100 XOR 3, 100 XOR 3 will just add 3 straight up, and then plus 1, right? So plus 1 will add 1. So if first bit is set, then it is becoming n. If it is not, then it's becoming n plus 4. So we have to avoid this operation. So if it becomes n plus 4, n plus 4, then n plus 4 then does not change anything in the first two bits, right? Okay, fine. Let's analyze now odd numbers. If n is odd, then what happens is 3s are n plus 1. So it's like this. So if first bit is set, then what happens is this is also set. So it will become XOR 3. So both the bits will become unset, and then plus 1. So it is conditionally becoming minus 2. It's becoming n minus 2. Else what is happening? If this is unset like this 101, so 3 XOR. So this becomes unset, this becomes set, and then plus 1, plus 2. So I am getting only OR operation is n by 2. So I can only do n by 2. Let's ignore n and plus 4. We can only do n by 2 and then n minus 2 if first bit is set. Okay, now let's see the no cases. 10 is no. 10 by 2, 5. If the first bit is set, then n minus 2. Else n plus 2. So it's getting trapped. 9, no, 8, yes. Yes, fine. 6 is yes. 6 divided by 2, 3. 3 has both the bits set and minus 2 is nice. Then 4, yes, fine. 3, fine. 2, fine. 1, fine. 9. What happens with 9? 9 minus 2, okay, minus 2 plus 2 minus 2 stuck. Am I doing this correct? If n is odd and the first bit is set, then XOR 3 will make them unset and plus 1 just so it's becoming minus 2. So if a number can be done like by 2 by 2 by 2, so if the number is like in this form 1 1 and then any number of zeros, only then it's possible. Or 1 0 0 0. Only then it's possible, right? 1 is fine, 2 is fine, 3 is the same case, 4 is the same case, 5 is not, 6 is the same case, 7 is not, 8 is the same case, 9 is not, 10 is not. So this is the answer, I think. So uh, if the number, okay, fine, till the number is even, I have to left shift it by 2. While n mod 2 is 0, n is greater than equal to 1, yes. While n mod 2 equals 0, I have to n left shift equal to 1, right? If n is less than equal to 3, see out, yes, else see out, no. Like it's 3 or 1 only, that's fine, otherwise it's not. Let's check. I have to also find the minimum number of operations. That should be easy if this is correct. Okay. I want to check my deductions once again. Choose to change either to 3's or n plus 1 or n by 2. So if n is even, the last bit is unset. I can do it n by 2, right? That's fine. Or 3's or n plus 1. If first bit is set, then we will first make it unset, the other bit is set, and then plus 1, then it makes it again set and then unset. So this still is remains n. Now if both are, if this one is not set, then we do XOR 3, so both become set, and we add 1, so it's like adding 3 and then 1, so it's like adding 4. So there might be a case if we add 4 here, we add 4 here to become what is this number? 4 plus 4 will become 8, and what is this? 8 for 12, 12 plus 4 will become 16. If it was this way, then plus 4 will become in case of 10, what happened was 1 0 1 0. If the first two bits are unset, or the number is 1 or 3, right? If the first two bits are unset and or no, or n is equal to 1 or n equals to 3, then yes, else no. I think this is fine, because whenever we have a case like this, now we can make this bit set by adding 4, then then this will happen, right? Then we can just left shift it, so left shift, then again add 4, then again left shift, then again add 4, right? Then again left shift, then again add 4, so this will become this, then left shift, left shift, left shift, then again, okay, yeah, that's fine. No, if I had this structure, so I can reduce it till that form, right? So while n remains, what I have to do is No, I don't need to do that. Is this correct? If the first two bits are unset, then we can eventually reduce it to, yeah, that's fine. So int first, the first bit, so it will be 1 left shift L by, oh, okay, so it's n and 1. First bit should be unset. This, okay, this is bool f and bool last. The second bit should be n and 1 left shift by 1. If f and s, or n equals to 1 or n equals to 3. Where did it fail? For 2, oh, 4. 4 has this. What happened at 4? Uh, if first two bits are unset. 3, okay, 2 is also fine, right? So n is less than equal to 3. 1 1 0. 6 is an exception, right? Can this be fine? Oh, this is fine. Can this be fine? Mm, this is 14. 8, 9, 10, 11, 12, 13, 14. 14 into by 2, then n minus, oh, no, does not work. We can do n plus 4, 1 0 0 1 0. Does not work. Does not work. So n is equals to 6 is also an exception. Uh, let's see, I'm very doubtful. Oh, 6 was also an exception. Great. And I have to now find the minimum operations to do so. So it should be easy, I think. So this is fine. Now anti-rest is equals to 0. Okay. If n is 2, what is this? 1. Else if n is 3, this is, what is this? 1. Yeah, n is 3. If n is 6, what happens then? We left shift and that's two operations, right? And in the else case, simply print -1 over here, right? Uh, get this. So we are aware of the -1 case now. Only the possible cases are here. Okay, if res, okay, remove this. If res is, if n is 2 or 3, then res is 1. If n is 6, then res is 2. Else, apart from that case, what happens is, uh, now, okay, now the first two bits are unset, right? For this number, what is the best answer? Like we will left shift, right shift, and then flip this bit using odd property. That's three operations. And if we do add one, then left shift, left, then right shift, right shift, right shift, right shift, four operation, and one five is wrong. So the best is to, if we have two consecutive left. So if basically it's 10, the number is, oh, so the number is 12. If the number is 12, this is important. If the number is 12, then we can end. If the number is 12, then we can end with three or more operations. Okay, another case would be if, okay, and 4, then end with two operations. So we have to do this while n is greater than equal to 4. Basically n is greater than 1. So what is the mask? Here mask is 1 LL left shift by 2, right? If n and mask, if it is set, then n plus equal to mask and operation plus plus. Else in right side was equal to once, operation plus operation, not I think rest we can do rest plus plus. Now here, if n is equal to 12, rest plus equal to 3 and we break. If n is 4, rest plus equal to 2 and we break. After that, let's print s or s. Correct. Let's go. Let's see the last problem. Cool. Interest accumulation. Let's check this out. For an array of size n, we define f as the following way. Start with calculus 0, your hand is empty. For each day, repeat the following steps in this order. If your hand is empty, you may choose to pick up the current item with the worth AI, you may choose not to. Score is 0 at the start. For each day, you uh, may choose to, if your hand is empty, you may choose to pick or you may choose not to. If your hand contains an item, you choose to sell the item and add its worth to score. Or again, you may choose not to. Okay. Add its worth to score. Yeah, sell it and add its worth to score. If your hand contains an item till now, then the item's worth increases by 1 due to interest. Okay. Your hand should be empty at the end of the instance. Further, note that it is impossible for your hand to contain two items at the same time. F is the maximum possible score possible. Sum of worth of items sold. That is, I think, some kind of DP problem. Easier. But I have to calculate n. Okay, for all sub-arrays. Okay. Okay, if I see this problem and I don't see this right now. So for the ith day, I have, so basically I have a state of where my hand is empty, where my hand contains an item of some worth. So my hand contains an item worth something, or yeah, so if my hand contains an item, I can also update which item it should contain, right? Note that it is impossible for a hand to contain two items at the same time. Okay, let's see if for each subarray I have to calculate. If I forget the DP for 1 second, for the subarrays, if your hand is empty, so I can choose an item and okay. So I can pick an element, increase its worth, and sell. Okay, negative items. Whew. Uh, mm, mm, mm. I have to compute ALR. So, can I say for subarrays ending at R, mm, like subarray ending at -7? So I sell for its own worth, right? We want f of 10, so you can choose to pick item and just sell it. Uh, if your hand is empty, you may choose to pick up the current item. So I can just buy and sell on the same day for 1 to 2, then I can add 1 to the worth. So for a single savar, I can pick and sell. For two length subarrays, I can pick and then sell, or pick and sell, like pick and then sell on the next day, or this element I can pick and sell. I don't have this option for the last element of picking and selling later. So from these two options, I'll choose, like I have to pick this and sell this, or sell, pick and sell directly. Then for the next pair, and then for the next pair, okay. Or I can pick and sell on the same day from the same day, then it's fine. Let's see how much will each element contribute. Can I see in that way? Excuse me. For subarray, okay, for the element 10, it will contribute to its own one length subarray, obviously. Then for the next subarray of length 2, either it will contribute itself plus 1, or it will contribute the next element. Similarly for subarray length 3 starting at I, this plus 1, it will fail only if it is 12 or something. So I have an n square solution where I find, like, till when will 10 be the one contributing. So 10 plus 1, 11. If the next number is less than 11, that will contribute here for the subarray of length 2 starting at 1. Then if the next element is less than 12, because 10 plus 1, then it will contribute there. Once this fails, it will stop contributing because there's a better person contributing. So if I can find for 10, can I find for the next number as well? Like, okay, insert 10 in the stack, and then for the next element, if it is 11, I just insert it in the stack. Okay. Now suppose there's 9. Phil, when will 9 contribute? Suppose it fails here. So I can do that in big of n, I think. Till where will this element contribute? Let's see if I can do something. Vector int contribute till which index? Okay, so contr n. Push. I'll say I'll push the I, the index 0 there. For int equals to 1 is less than n, what I'll do is, okay, yep. The current value for the, it will be st dot top. Let's say this idx is st dot top. val is, I'll find the value at idx, and then I'll add to it, I'll find the value at idx. Okay, found. Now I'll add I minus idx to it. Yes, yeah, right. So this is a new value. If value is less than, if value is less than, this is kind of a do loop. If value is less than vi, the current element is greater, so it will still contribute. For equal elements we fail, right? Let's say we insert equal elements in the stack. So if val is less than vi, is less than equal to vi, then stack dot pop first of all. Country of idx is still mm, I. Let's say I'm okay. Let's say I can. We'll calculate that later. The country is still here. Now I have popped from it. Else I'll do something. Let's for now. Let's do this while true. If val is less than equal to vi, then country I have put, then it's popped. Now if value I've calculated is greater, then I should break out from here. Should I? If the value of calculated is greater. Okay, and if st dot empty, then also I should break. Yep, break, but after pushing, right? st dot push I. Push I, right? Push I. st dot push. Let's push I. So we have calculated the contributions. Country of idx will be I till I, right? Hmm, this is the modulo int template. Fine, cool. Where will we have to calculate the result now? INT contributions will be for the value vi and summation of I minus contribute till I minus 1. Contribute till I minus 1, right? So it is summation 0. There will be summation 1, no. 2 minus current index will be 2. Summation Hmm. Oh, I'm on this one. After the summation, this one. AI into country of IDX minus I summation. Okay, summation will be country at IDX minus I country at IDX minus I plus 1 by 2 country of I. Then I have to multiply this with sum. The sum will be added, but country I minus I hmm, plus sum. What happened? What is the issue here? Let's do this. Now my printer is zeros. What the hell? Okay, 0 I less than 9 I plus plus C out country of I country of I. Okay, 0 is pushed and IDX is 0 top, val is B of IDX 5 plus 5 plus 1 will be 6. 6 is less than equal to no, and 6 is okay. So I'll push over this ith index and break. Then for the next element, right now country is not been assigned, right? Now for 8, uh, val less than equal to vi, right? So country of idx equals to I minus 1, correct? Then st dot pop, fine. Then idx st dot top val equals to v of idx plus I minus idx, that is 7. And this happens, so country is still I minus 1. True. Okay, fine. So vi into country I minus I. Okay, what am I doing? This is 24. Okay, so both are 2. What happens with this is, okay, it should be n minus 1. But, what happens here, man? Okay, 1, 1 and 2. So similar elements, similar ones will be skipped. If I is greater than 0 and country I equals to country of I minus 1, you can just skip. 19? What? 5? If 5 will contribute it till here. Okay, I missed a lot of things. 5 can be picked till this uh, 0th index and the first index. Then if the complete subarray, I'll pick 8. This has a max country till this, and this has a max country till this. Then it will just contribute till the so a number will contribute 112. 5 will contribute till 5, 5 minus 7, and 8 will contribute till 5 plus 6, 11, so I need 30 more. What? So 8 will contribute in all the values after this till its max country, and also for the indices which said that I will end my max country before 8. Since we are considering 8, that means everyone before this has said I will end the max country. So 2 more people will go for 8. 5 goes till this, the 5 plus 6, 11. Okay, 6, 11. Then 8, 11 plus 8, and then plus 8 here and plus 8 here. So 105 here. 0, 8, 5 plus 6. No, 6, only 6. Uh, 5 and minus 7. So I pick 5, sell at 6. Uh, so I pick 8 and sell at 8. Pick 5, sell at 6, and pick 8, sell at 8. 8 at 16, 24, 12 and 5, 17, 41. So 5 is contributing to 5. 5 plus 1 6 and 5 plus 1 6. So this will contribute in all the sub-arrays ahead of it, and 8 will contribute all the sub-arrays ahead of it multiplied by the number of indices preceding it. So yeah, 5 will contribute to so first I have to calculate this 5 plus 6 plus 6. Okay, I have done it already somewhere. 5 plus 6 I have calculated, I think. Till the contrary I have. So 5 times the, no, it's like 5 plus 6. So 5 if we take it out from both. So let's say 5 into 2. So it was 5 into 5 into, so it's like Vi into contrary I minus I. Because I've chosen this minus this. This is inclusive. So I plus 1 and plus 2. So Vi into contrary I minus I plus 2 into contrary I minus I plus 1 by 2. This is the sum. So let's check for 1. We have 5 into contrary I is 1, 1 minus 1 plus 1. So it's summation of 1. Really? Contrary I minus I plus 1. So 1 minus 0 plus 1. That's 2. Summation 2. Right, summation 2. I needed summation 2. So it's 5 into summation 2. 5 into 3. No, it's not like that. It's 5 into something plus summation. 5 into something plus this summation. 5 into the number of elements, that is contrary I minus I plus 1. These many elements in this. Now to sum, I need to add something, the extra elements in the final value. So it's like the final val I have is Vi plus. If contrary I is this much, so I'll have to subtract and add one more. No, you subtract just contrary I minus 1. I minus I. This much I have to add in Vi. Vi plus contrary I minus I. Contrary I minus I. Yeah, I've added. So this is the final value. And the final value will be up till the rest of the array. N minus 1 minus contrary I. N minus 1 minus contrary I into final val. This will add in the sum. Okay, so this much is added. Now I have to multiply this with okay uh, ZC modify this ZC equals to I have to take sum multiplied by I plus 1 and just plus equal to C. Okay. Might be close. I see. That's why 1 and 1. Mm, 23 got added. Why? So I have I plus 1 is just 1, so that is fine. And so what is sum here? Sum was already 23. 5 plus 6, that is 17. Oh, 10. So 10 plus 11. It's 10 plus 11, right? Okay, so it's 10 into 10 into 2, right? It's 20. Then it is contrary I minus I plus 1 summation 2. So not summation 2, right? Hmm. Okay, I got 21 and 41. Let's check some overflow is happening. I might use this. 3333. I can use this till 3? No. Only if v is greater than 0, then we'll push it. If v0 is greater than 0, only then push 0. And at the end, this happens, so all will remain still minus 1. Right, so it is all are minus 1, or the contrary I is minus 1. Then you keep on continuing. Nice. Let's see. It's 21, 41, 0, 18. Okay, 18 is a mistake. Okay, let's see. Ah, greater than equal to 0. What happened here? 2, 1, 2, 3. 1, 0 can be used till here. Ah, correct. But I have something called max country. Max country equals to max of max country and country I. If country I is less than equal to max country, then you can continue. 21, 41, 0, 17 failed still. Okay. This is 2. So it is 0 plus 1 plus 2, that's 3. And 3 will contribute to, okay, 0 contributed to all. Let's remove this and try something else. If country I is minus n, only then it will continue. Or let's say vi is less than 0, then you have to continue. Okay, 23. Okay, this also is close. I am very close now. 2, 1, 2, 3, right? So 2 will contribute 3, right? I got 3. So I get sum and C. Sum is 5. Am I getting different answers? No, it's fine. Sum is 5. 5? How come? It is 2, 1, 2, 3. Okay. This I plus 1 is wrong. Like, uh, 5. Then it's 2, 6, 3, 12. I've got the mistake, but I'm thinking how to implement it. The mistake is choosing sum into I plus 1. Like, uh, this 1 will not contribute to a sub-array starting at 0, but will contribute to a sub-array starting at minus 1. So what is the significance is that the max quantity of minus 1 is significantly lesser. So for any quantity, till which quantity is the uh, country lesser than this? Till which quantity is the is lesser than this? I have to find the first index to the left of I such that its country is greater than the country at I. Greater than or greater than equal to? Mm, if I find greater than equal to 2, it includes this. So greater than I. So I have to find the smallest index whose country index is, if the country index of this is greater. Yeah, so country index of this is first element whose country index is greater. First element, first index to the left of I such that country IDX is country index is less than, is greater than equal to I. First index to the left of I such that country index is greater than equal to I. This is also done by stack, I think. If I start inserting from the right index and if the country is greater than equal to, then I've got it, then I've got it, then I've got it, else I'll just push this also. So vector int left of n is -1, uh, stack in stl and stl dot push n-1. Okay. For int I equals to n-2, I is greater than equal to 0, I minus minus. First index to the left of I such that country index is greater than equal to I, while not of stl.empty and country of I is greater than equal to st.top. So st.pop. Like if the top element is less than equal to the counter of I, then st.pop. And left of st.top equals to I plus 1. Till then it is valid, right? Till then it is valid. And now I will push I, it is stl, while not of stl dot empty, left of st dot top equals to 0 and st dot pop, because if not it will go till the 0th position. Now I have this, so it is I minus left of I. This one, let's try. What? Some problem here. What? Still, it is stl. stl. 21, 41, 0, 21. Some gibberish output. This one is correct now. Okay, this should be simple case. It is 1e, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1e9. Is it the max? 1e9. All will contribute till 3. Left of I 0, 1, 2, 3. Okay. One e9, then plus 1. Assume the modulo is greater than this huge modulo. Let's take this as 1e12. Now try this out. What is happening? Okay, so in this it is 4 into 1 9. Here it is 1 plus 1 9 plus 1 9, 1 9 plus 1 9, 1 9 plus 1 9, 4 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 into out int of 20 into 29 mod m. Hmm? It's not 20, so it's like 1, 2, 3, 4, 5, and 4, 9, 29. That's fine. 29 plus 29 plus 29 plus 29, right? Then 29 plus 49, then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Ah, 20 into 29. I'm pretty sure this is the answer. 20 into 29, right? 20 into 29. So what's going wrong here? Let's do m again 1 into 12 and see what is wrong here. 4 e9 plus 6. Why plus 6, man? This is not required. So for this element, max contrary find is not needed. Sum is vi into contrary I minus I plus 1, vi into contrary I minus I plus 1, that is 3 minus 0 plus 1, 4, vi into 4 plus, no. The contrary is calculated wrong. I think if I change this, but I get 19 here. Ouch. How to get this correct? It is less than. Let's try less than. It should be. Now it is 21, 41, 0, 19 and 2. Okay, this fine. Let's set modulo again. Just one more thing is going wrong and then it should work. 21, 41, 0 and this is 19 error. What? 29 validated here. My contrary calculation is wrong because 1e9, when jumping here, it's better to take 2 into 1e9 rather than 1e9 plus 1. Ah, okay. Mm, decent enough rank, I say.